Hello and welcome to Statecraft IAS Academy. I am Atif and we have started an initiative where we are connecting most of important current affairs with the static content to help you understand better how you should actually approach studies. Now, recently you might have heard about a heat wave in Europe, a very unfortunate event that killed more than 2,000 people within 72 hours. A heat wave so devastating that the situation where government used water on people to help them cool down while they work. That was the situation in Europe. But the question is, why was the situation so worse? What were the factors that were responsible for all this? Well, of course, we will learn them one by one. The main thing that you need to know about is heat dome. A heat dome formed that led to so high temperatures. And what is the factor behind a heat dome? Jet stream. So for the heat dome, you have to understand how jet stream actually works. And that's our plan today. What we are going to do is, we will learn about jet stream first, how a jet stream is formed, and then we will link it with the heat wave in Europe, and then other extremes of the climate as well. There are some other important events that take place because of jet stream. So we should know about that as well. But right now, let us start our class with the very first thing, that is the heat wave in Europe. This was a news covered by the Mint where 1029 people died because of heat wave. It's on 1st of July. In these countries, more than 1000 people died. And other countries like Italy and we have Spain, the situation was even worse. So let's go back and start learning it from very basics. First thing, this is the map of the world and we know about equator. Equator passes through these areas and we have Tropic of Cancer and Tropic of Capricorn. Now, one thing I tell you is that these are the regions between Tropic of Cancer and Tropic of Capricorn that are the hottest regions on entire planet. We have some of the hottest regions in this very area. But there's one confusion. When we talk of Europe, it's located beyond Tropic of Cancer, or we can say it is located in temperate areas. Temperate areas, when we talk of these regions, these are not hot. These areas are predominantly very moderate as far as the temperature is concerned. Then why has heat wave been so devastating these regions? That's what you need to understand. Before you go to jet stream, you need to understand about geostrophic wind. What is a geostrophic wind? If you've seen the last class, I told you about atmospheric circulation, how Hartley cell is formed, how Ferrel cell is formed, polar cell, everything I told you. And I told you about the direction, how the wind moves, how the Coriolis force, all the forces that are responsible. Today we have to learn about geostrophic wind. What's a geostrophic wind? It is an atmospheric circulation that takes place 5-6 kilometers and above. It's not located on ground. And that is the primary reason the geostrophic wind shows different behavior as compared to other atmospheric circulations that we have seen. There are certain factors that are responsible for this. But let me tell you something. If you have seen the class, everything will be a cakewalk for you. Nothing will be difficult. Because the basics lie in that class only. Here we're only going to build on that. What is this diagram? I'll tell you in a bit. We'll get back to this. First of all, I have to tell you about some basics. Now, this is an image you're already familiar with. We have learned about this, how the things are. Let me just give you a brief overview. This is the pressure gradient force. And we have Coriolis force. And we have drag force, or what we say, frictional force. And eventually, when we see the resultant of pressure gradient force and Coriolis force, we get the direction of wind. This is the direction of wind. In simple words, I will tell you, if we have a gradient force like this, listen to me very carefully. This is how you will understand jet streams. This is the basic. So pay attention. This is a pressure gradient force. And we're talking of the ground level. On ground, there's a very strong frictional force. And what is the role of frictional force? It slows down the speed of wind. It causes the speed of the wind to fall. And because of slow speed, you already know, I have already told this thing that whenever the speed is less, Coriolis force will be less. And if the speed of wind is more, Coriolis force will be more. When we talk of ground level, the frictional force is very high. And because of that, the speed of the wind is less. So Coriolis force is not that high. We get a Coriolis force like this. Let's say we have a friction force and this is a pressure gradient force. This is Coriolis force. I told you, whenever you have to look at the direction of wind, it will always be a resultant of pressure gradient force and Coriolis force. So what is the resultant? This is the resultant. That will be the direction of wind. Let me write it down. This is wind. Now, let us start our journey up. As we start to go high, what we see is the frictional force will start to reduce. I gave you a very good example. If I am rubbing my two hands, there will be more friction. If I just start lifting my hands up, the friction will reduce. As we go up, as the altitude increases, the frictional force will decrease. And if the frictional force is decreasing, the speed of wind will start to increase. And the speed of wind will increase. What will it lead to? It will lead to an increase in Coriolis force. That means the speed of wind will increase and Coriolis force will start to increase as well. We will get a wind direction like this, because again we have to look at the resultant. This is the wind direction, this is the pressure gradient force, and this is the Coriolis force. A time will come when we will reach maybe 5, maybe 6 kilometers. There's no fixed distance. First of all, let me tell you, you will never see a fixed distance. If somebody is telling you there's a fixed distance where frictional force will totally disappear, that's wrong. There is no fixed distance. But let's say we go up 5 kilometers, 6 kilometers, and we see the frictional force totally disappears. There is no frictional force. What's going to happen at that place? What do you think? Listen to me very carefully. This is pressure gradient force. There is no frictional force. So Coriolis force will totally balance out the pressure gradient force because there is no frictional force. And what will be the direction of wind? Direction of wind is resultant of the two. This will be the direction of wind. There will be very huge deflection because of Coriolis force. Why? Because of absence of frictional force. Ideally, the wind should have been like this. Pressure gradient force is acting like this. This should have been the ideal direction. But Coriolis force has modified the direction. I told you in the very first class that the main role of Coriolis force is to change the direction. It does not impact the speed of the wind, although the speed of the wind does impact Coriolis force, but the vice versa is not true. That is why I'm telling you, when the Coriolis force will balance out the pressure gradient force, we will have a wind that will blow parallel to isobars like this. We have a wind that's blowing parallel to isobars. This is exactly what we say a gradient wind. When a wind starts to blow parallel to isobars or perpendicular to pressure gradient force. You know about perpendicular and parallel. Whenever there is a 90-degree angle, we say it is perpendicular. So if we have a pressure gradient force like this and we will have a wind perpendicular to pressure gradient force, this is known as gradient wind. You should know about it because this is what we are going to exactly use in our jet stream. I will explain you how. Now listen. Sorry. When we talk of gradient wind, look at this diagram now. Now it's a bit more easy for you to understand. First image is the image at ground level where we have frictional force as well, and this is the direction of wind. This is the gradient force, this is the Coriolis force. Then we go higher and the frictional force will start to disappear and the wind will start to become parallel to isobars. Eventually, when we reach at a certain height, you see, when we reach at this height, we have this pressure gradient force and Coriolis force. And eventually the wind will start to blow parallel to isobars. That is exactly what we call as geostrophic wind. I hope your concept of geostrophic wind is clear. You have any confusion? Kindly drop your confusions in the comment. I will get back to you. Now, let's go to, there's some overwriting. Sorry for this. This is jet stream. Now we will come to our main topic of jet streams. What is a jet stream? Jet stream is a fast wind that blows in upper atmosphere. First things first, when we talk of upper atmosphere, what are we talking of? 5 kilometers, 6 kilometers, 10 kilometers higher. So that is a geostrophic wind. That's what we're talking about, right? That means jet stream is a geostrophic wind. It is a fast flowing wind, sometimes reaching speeds of even up to 300 miles per hour. That's a very high speed. So this is a fast moving band of air. Usually it blows from west to east. I will explain you why it blows from west to east. I'll clear you all this. Don't worry, relax. You don't have to worry about anything. I'm here for you. And this jet stream influences the weather patterns. And that is exactly how we will link this thing to our current affairs news today. How heat waves and extreme events are impacted because of jet streams. Because jet stream is responsible for different weather patterns across the globe. We have two types of jet streams, first of all. One, what we say is permanent. These are permanent. These blow throughout the year. We have these winds that are present throughout the year. And second, these are seasonal or temporary jet streams. That means they're not present throughout the year, they're temporary. When we talk of permanent jet streams, we have two types of jet streams. One, polar jet stream. Second, subtropical jet stream. These are two jet streams that are permanent. What is the meaning of permanent? That is, they will be present throughout the year. Then we come to seasonal or temporary jet streams. These are temporary, you will not find them throughout the year. I'll give you one example. We talk of tropical easterly jet. This is active during summer and monsoon season in India. And these are responsible for monsoon. Well, we will learn about them, of course. When we talk of these winds or jets, these are something that are very important for your monsoon concept. We will get back to that as well. We will come to our monsoon lecture. There I will explain you how tropical easterly jet helps strengthening the monsoon, how Somali jet helps in the monsoon. All these things we'll learn when we reach there. But right now, our concern is permanent jet stream. Permanent jet streams is right now our topic. First of all, if you are making your notes, kindly do me a favor. Start your notes with these two only right now because this is what we are going to learn about today. So, under permanent jet streams, we have two types of jet streams. One is a polar jet stream and second one is a subtropical jet stream. Polar jet and subtropical jet. If you look at this image, look at this blue. The blue one is a polar jet, blue one. Okay, this is a polar jet. And the red or orange or whatever color it is, I don't know exactly. Sorry. This one is a subtropical jet stream. Okay. These are the two jet streams that we have to learn about. Now, listen to me very carefully. These are the two jet streams that are present in both the hemispheres. This is equator, you know about it. This is the northern hemisphere. This is the southern hemisphere. In both the hemispheres, the jet streams are present. You can see we have southern hemisphere as well where the jet streams are present. And these are circumpolar. What is the meaning of circumpolar? That is, they blow throughout the globe. You see, everywhere they are present. It's not that they are present only over, let's say, Asia or Europe or US. No, they are present everywhere. Throughout the earth, you will find these jet streams. These are circumpolar. That's the meaning of these are the jet streams that blow along the earth. Two permanent jet streams in both the hemispheres. Okay. Now, let's get an idea of their formation, because their formation plays a very important role in your understanding of all the concepts related to jet stream, how you should answer them, how you should be able to link them to current affairs, to weather extremes, heat waves, other polar vortex. We will learn about them. If you've seen the last class, I discussed certain things, and I'm pretty sure if you've seen the class, you will be aware of this image that is in front of you right now. What does this image show? This shows the atmospheric circulation. Okay, this is the atmospheric circulation, general atmospheric circulation, where we learned about the air being lighter around the equator, rises up, then sinks at around 30 degrees. Then again the same thing, Hartley cell, Ferrel cell, polar cell. Kindly, I'm not going to repeat all this, otherwise it will take a lot of time. We already learned about this. Jet streams are formed along the margins of these cells. One formed along a margin of Hartley cell and Ferrel cell, and one along the margin of Ferrel cell and polar cell. Okay, these are jet streams that are formed. But why are they formed? What is the exact concept? For that thing to understand, you should be aware of these things. So kindly go through the class if you're not seen that, so that you understand what I'm going to talk about now. This is a very technical thing. I want you to understand this very carefully. Listen to me carefully. Surface of Earth, 0 degree. I'm going to talk about this thing in only one hemisphere, in northern hemisphere. And I told you, whatever I'm talking of in northern hemisphere applies in the southern hemisphere as well. Okay, now listen. I told you about something about the cells that air rises, then goes up, and then comes down, and then sinks. Correct? Then there is second cell where the air goes up, something like this. And then we have finally the polar cell that comes down at 90 degrees. This is 0 degree. This is 30 degree. This is 60 degree. Okay. This is how the general atmospheric circulation works. And when I talk of jet streams, we will find jet streams somewhere here, somewhere here. This is Hartley cell. This is Ferrel cell. This is polar cell. Look at this. This is how the troposphere is. I told you in the very first class that the actual shape of troposphere is like this. Highest along the equator and lowest at poles. That means it's slanting downwards. That's very much visible here. You don't have to worry too much. And this is how now we will learn about jet stream. Listen to me very carefully. I want to ask you guys something. Kindly tell me in the comments. Let's say I'm going to draw a more refined image now. The image is same. Let's say this is a Hartley cell. Oh, my drawing unfortunately is very bad, but I know you will understand that. This is Ferrel cell and this is polar cell. Okay, let's suppose we have 100 particles of air. This is hypothetical. Of course, the concentration varies from one place to another. But let's say we have 100 particles of air present all along the regions. That's what I mean, is that we have 100 particles of air here. Okay, 100 particles of air in this region and 100 particles in this region. Clear? Now, listen to me very carefully what I'm going to say. 100 particles in each and every place. Let's say this is A, and at the same level we come here. This is A dash. This is A dash. Okay? Tell me something, where you think will be more pressure? At A or A dash? Give me a second, let me just make a diagram a bit more clearer so that you understand properly. Well, of course, I'm not good at making diagrams, especially this is the region around the equator, okay, where we have 100 cells, 100 air particles, okay. Then we have another region around the subtropical region or the feral cell, where we will have 100 particles of air, okay. And then we have polar region, where we will have another 100 particles. Everywhere we have 100 particles. This is a region, here we have A dash, and at the same time we have A. Tell me, this is A dash, this is A. Tell me where you think will be more pressure, at A dash or A. Look at me. Leave this screen and look at me. This is my head, okay? Yeah. There is nothing on my head right now. There is nothing on my head. So there will be no pressure. Why will there be any pressure? There's nothing on my head. So there will be no pressure. Now, if I put something on my head, let's say I am putting my two hands on my head. So the pressure will start to increase on my head, right? This is very obvious. There's nothing on my head, no pressure. Hands on my head, pressure. Same thing applies here. At A dash, there is nothing from above. So there will be less pressure. At the same time, when you look at A, at this region, there will be this much of pressure. These many air parcels will be applying pressure. So comparatively, between the two, I'm not talking of the entire Earth. I'm talking between the 2 points, that's A and A dash. Since there is nothing above A dash, there will be less pressure. At the same time, there will be some pressure at A. That means the pressure at A will be more than A dash. Am I right? I hope there's no confusion. Okay. Now, I've told you already, whenever we talk of flow of air, it flows from high pressure to low pressure. And we have high pressure at A and low pressure at A dash. So the wind will start to blow from A towards A dash like this. Right? Why? Because between the 2 points, when we look between the two, at A dash there is less pressure as compared to A. That is why the wind will start to blow from A towards A dash. This much is clear, I hope. Coming to our next point, that is this. Let's say this is B dash and this is B, okay? Where will be high pressure? Again, the same concept. Nothing above, this much up, air above. So high pressure at B. Same thing that I've told you already here. High pressure at B, low pressure at B dash. Wind will start to blow from B towards B dash. Why? Because B is comparatively at higher pressure as compared to B dash. So the wind will start to blow from B towards B dash. So these are the two winds that will start to blow. A towards A dash and B towards B dash. Now, let's get back to this point. Listen to me very carefully. Let me clear this. Let me draw this thing on the globe now. And keep this thing in mind. When I'm talking about these things, I'm discussing about the upper atmospheric circulation. It's not something that's taking place at lower levels. It's not something that's taking place at ground level. I'm talking about something that's taking place at higher level, upper atmosphere. Okay? This is equator. This is the subtropical high pressure. This is the subpolar low pressure. And this is the pole. What I told you already here is, look at this. I told you from equator, the wind will start to blow towards subpolar high in the upper atmosphere. Keep this thing in mind, don't get confused between the two. That means from equator towards this region, right? This is how the wind should blow. Why? Because in the upper atmosphere, we have high pressure here, low pressure here, between the two, comparatively. At the same time, now get back to this. Where did you go? Sorry. From B to B dash, from subtropical towards subpolar. Again, high pressure towards low pressure. That means the wind will start to blow from here towards here. Why? Because between the two, we have high pressure here and low pressure here. So this should be the direction of wind. What? Ideally, this should have been the direction of wind. But, but, Coriolis force will play its role. Now, revise what I told you in gradient wind. I told you, whenever we have a pressure gradient force like this, in the upper atmosphere, there is no frictional force. Coriolis force will balance out the two and the wind will start to blow in this direction. So instead of blowing like this, the wind will start to blow like this. Between the pressure gradient force and Coriolis force. This is exactly the direction of wind. This is how the wind will start to blow. And this is what a jet stream is. Now, why will the wind blow in this direction? Because the direction will be towards right in the northern hemisphere. If we talk of southern hemisphere, ideally the wind should have been like this, but it will be deflected towards left. And when you deflect it towards left, it will be from west to east. I hope you're understanding what I'm trying to tell you. Things are interconnected. For the heat wave, you need to understand how the gradient wind will work and how jet streams work. And this is how the jet streams start to blow. Now, there is one more confusion. Look at this image. They are not blowing like this. They're blowing something like this. Meandering. They're not blowing in the straight direction. They are meandering. Why are they meandering? What's the reason? The main reason, of course, there are many reasons, but the main reason for the meandering of jet streams is the difference in temperature. There is high temperature that will raise the air to higher regions in certain places. Let me explain this, don't get confused. Let's say we have some region where the temperature is more, so the air parcels will be lifted high, very high. Again, you go to some other places where the temperature is comparatively less, so the air will not be that much high. Then again, we'll get a region where the air will be very high because of high temperature. Okay, because of this thing, the jet stream will start to meander between the, because it's the temperature that determines the movement, that determines the meandering, and then of course rotation of the earth will lead to the Coriolis force. So this causes meandering. If the temperature would have been the same throughout the earth, then it would have been very straight like this. But since the temperature is not same, somewhere high, somewhere low, somewhere high again, so it will start to meander. Jet stream will not blow straight. It will start to meander. What is meandering? Meandering is this path. So that is why the jet stream blows somewhat like this, up and down. Now, do you understand why we have two permanent jet streams? One polar jet stream and one subtropical jet stream. I hope this is clear why there are two jet streams. Because if you have seen the last class, I told you about this is equator, this is subpolar area, this is polar, sorry, my bad, this is subtropical area, subpolar area, and then we have poles. These are atmospheric circulations that are present throughout the earth. This thing, these winds are present throughout the earth, right? Throughout the year. Present throughout the year. So that is why we have these permanent jet streams, because of this atmospheric circulation that we learned in the previous class. Are you able to understand? If you have any confusion, kindly let me know. I will repeat it 10 times, but it should be clear to you. This is the movement of jet stream. Now, if we take a look at this, so we will have, let's say, a jet stream that will start to blow on Earth, one along the 60 degrees. This is called as polar jet. One along this region, 30 degrees, high pressure, subtropical jet. Same thing will be in the southern hemisphere as well. Of course, I told you. Same thing will be in the southern hemisphere as well. Direction and all, I think this is clear. This is very much clear. I cleared all this thing in the previous class, so we don't need to repeat that thing. Now the question, how is this jet stream responsible for the recent devastation in Europe? How? Because the jet stream is not merely the wind that's blowing in the upper atmosphere. It is a strong wind that impacts the atmospheric circulation. Listen to me carefully. When a jet stream starts to blow, it starts to meander because of temperature difference. This is a jet stream. It's blowing like this in the upper atmosphere. Sometimes, normally it's because of global warming mostly. The temperatures have increased. You know about it. Global warming is something that's real. Of course, Donald Trump once said that there's no global warming, but that's what he believes. But global warming is real. What's happening sometimes is there's intense heating, there's intense temperature, or there are some other regions. Because of that, the meandering becomes very much intense. The meandering becomes intense. Okay? The meandering increases so much in certain events that what we see is there becomes an omega block. Look at me. What happens is this is a region. This is how a meander starts to form. A very strong meander. This is jet stream. This is jet stream. But there is intense meandering in jet stream. You see, this is very intense meandering. This one. Intense meandering starts to take place. And what this causes is this starts to trap air. We have low pressure on one side, high pressure on other side. Low pressure on one side. Okay. Now, why is this low pressure, high pressure? For this, you need to learn Ballard's law and other things. Right now, we will not go into that much of detail. That's very something for optional level knowledge. You don't need that for GS. Okay. So what happens in this omega block? Why is this omega block? You know about a letter that's like this. You might have learned about this in physics. This is called omega, right? And this is resembling something like omega. It traps high pressure in this omega, and that is what causes a heat wave. How? Now, I'll show you only this much. I'll cut this much here and draw it. This omega block I'm showing you. Okay, I hope you are understanding that this is basically a jet stream that is meandering too much. Listen, this is a jet stream that is blowing and an omega block is formed. Okay, high pressure, omega block, high pressure. What happens is sun is beating down constantly. It is increasing the temperature of ground. The temperature is increasing here. Now air, what happens? I told you already, whenever the temperature increases on ground, the air starts to rise. The air will start to rise. Normally what happens is, you might have heard about it, you might have seen it around you as well. Whenever the ground heats, the air starts to rise, it will go up. The air will go up, form clouds, and it will eventually rain. Right? The air will go up, it will form clouds, and there will be rainfall. But in this case, when the air will start to go up, we already have high pressure because of the jet stream. How is the air supposed to go up? If there is already high pressure, I've told you the air goes from low pressure to high pressure. But already the condition that exists here is high pressure. So will the air be able to go to high pressure? It will be against the law of nature. It will be against law of nature. You cannot expect the water to flow upslope. Can you expect that? No. Similarly, you cannot expect the air to go up when there is already a high pressure system. So what happens is that the high pressure pushes the wind down. It pushes the wind back. It starts to push the wind back. The air is not able to go up despite of intense heating of the ground. It heats up. The temperatures start to rise. The temperatures start to rise, and because of the rising temperatures we see the heat wave like conditions. Because of this very high pressure, it keeps pushing the air down. It's not only because of this thing, you see the air that comes down, it will also start to heat up. That's adiabatic heating. That's different concept, we will learn about that. But right now you understand that whenever the air starts to come down, it heats up. Already the ground is very hot because the sun is already present there. Now what should have happened ideally is that the air would have gone up, formed clouds here and caused rainfall. But this acts as a watchman. It doesn't allow the air to go up. The high pressure system does not allow the air to go up. It constantly pushes the air down. That further heats the cause and the temperatures rise. We see the condition called heat wave. Now you imagine constantly the sun is there. The temperatures are rising. We want rainfall, but there is no rain. Why? Because in the previous lecture, I already told you rainfall. When does it take place? When the air rises, cools down, forms clouds. You go to the equator. Here, where is the image? This one. You see, the air is going up, right? It cools down, causes rainfall. Again, here, the air is going up, forms clouds. Whenever the air will come down, we see aridity. This is something that I already discussed with you. The same thing is happening here as well. The air is not going up because of high pressure. It's only getting pushed down and the temperatures further increase. And this led to the heat wave in Europe. This is how the concept of heat wave that you might have gone through newspapers and all. This is what heat wave is. Now, two things that you need to know here is that this is omega block. You might get a question in exam. What is the role of omega block in the heat wave? I mean, they will play with the words. You should know all the words that are associated. They might play with words. The question will be very much like, what is the impact of omega block on the climate extremes? Or we say a heat dome. Look at this. This is the same thing. Again, the jet stream would have been blowing from here. It would have eventually led to formation of an omega block here. And this formed the shape of a dome. It's one and the same thing. You might be asked about omega block. You might be asked about heat dome, effect of heat wave. There are other factors for heat domes as well, but right now I'm talking of this thing. If you look at these arrows, you can see the air trying to go up. You see these arrows trying to go up, trying to go up, but then we have high pressure conditions because of the jet stream, meandering of jet stream, which constantly pushes the air down. When it keeps pushing the air down, it does two things. It does not allow the formation of clouds. It doesn't allow the formation of clouds because the high temperature, the air is not allowed to go up beyond a limit. And because the air is getting pushed down, it heats the ground. The ground becomes extremely hot. And this is what we call as heat wave. Clear about heat wave? Any confusion, anything, kindly let me know. I will tell you. No problem. Now, there's one thing. These images surfaced on internet. Unfortunately, we take our knowledge from internet. Well, there are good things on internet as well, but the sources should be reliable, like our channel, of course. Okay, so the images were like this: that the temperatures became so high that the railway platforms or the railway tracks started to bend, and people, without confirming, agree to this. Okay, yeah, the temperatures were so high that the railway tracks bent. But tell me something, these are made of steel and all, iron, whatever the material is used in it. Do you really think that they will bend because of this temperature? They will melt. They melt? They have a melting temperature of 1500 degrees. Do you really think a temperature of 40 degree will melt them? No, right? No. Then what happened here? Now, this is a concept of physics basically. I mean, you learn about physics and all. There is something where the thermal expansion concept comes in. You might have seen in flyovers or certain places, there is a small gap that's left between certain flyovers, little gap when you travel over a flyover or anything. Why? Because when the temperatures increase, the metals start to expand. This is natural. They start to expand. And it's not that the temperature will increase beyond certain limit and then only they will expand. No, no. They'll start to expand in lower temperatures as well. But the thing is that these small spaces are left so that whenever there is expansion, they can expand easily. Otherwise, if there is no space, let's say there is no space, what will happen? When they will expand, they will start to bend. That's what happened here. As per the European temperature, in the very first slide, I told you it's in temperate area. They might have left these spaces not that big, but since the temperatures were so high, these bent because of the bending of materials, expansion of materials, not because of melting. This is not because of melting, first of all. Take that thing out of your mind. It's not because of melting. Do you really think iron will melt because of 40-degree temperature? No. This is a concept of physics. When you learn this thing in physics, in science, you ask your teacher. That teacher can explain you this thing better. I'm not that good in this thing. But one thing is for sure, this is not melting. Clear? Let's continue our journey ahead. Now, this is how the jet stream is meandering and an omega block is formed and a high pressure condition is trapped here. And what caused high pressure? The air couldn't go up, and this is Italy. If you know about the map, if you don't know, we can do mapping sessions as well. That's not a problem. And the temperatures increased because the air was constantly being pushed down. The temperatures increased, and this led to the heat wave. Is the vice versa possible? If the high pressure is getting trapped, can the low pressure also get trapped? Yeah, of course. Why not? Certain, in some cases, if the low pressure gets trapped, what's gonna happen? Let's say a low pressure condition is above the ground, and this is a high pressure condition. This is scenario A, and this is scenario B. This is high pressure. Okay, I told you whenever there is high pressure, that it will not allow the air to rise up. It will push the air down, and there will be high temperature. Low pressure will attract more air. More air will start to rise. It will attract air. The way high pressure pushed the air down, the low pressure will attract more air. And what's going to happen? The cloud formation will be intense. There will be very, very heavy rainfall. If you're not aware of a condition in Spain where several centimeters of rainfall took place during the night, this was the condition there. There was a low pressure condition that was lying over Spain, and it attracted air from all the directions, formed strong clouds, and caused rainfall. Inverse of high pressure condition. Well, the same thing happened in 2019 World Cup as well. If you're a cricket enthusiast, let me know. I'll tell you what happened. Right now, we don't go into that thing. Okay? What you need to know is whenever a high pressure temperature gets trapped between two low pressures, it leads to heat wave, high temperatures. If a low pressure, then it will lead to intense rainfall. It will attract more and more air, more and more formation of clouds, more and more rainfall. Clear? This is the condition of heat wave in Europe. There is one more condition that we need to work on. That is polar vortex. Listen to me very carefully. What is polar vortex? This is Earth. On the poles, especially on the Arctic pole, what is there? There's a constant band of air that is moving with very high speed. Okay? Very high speed over the Arctic region. This is North Pole. Along the North Pole, there's a very strong band of air that's moving, cold. And we have polar easterly jet. What's that? We already learned about that. Polar easterly jet is already present here. And this vortex is stopped by this jet stream. It does not allow this polar vortex to come down. Why? As I told you, the jet stream is very strong. It's not something that we consider, okay, it's air, what's it gonna do anyway? No, 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 no. It's very strong. It does not allow this polar jet stream, does not allow this vortex to come down. What is polar vortex? How is it formed? Don't go into that. You will never be asked that. That I can assure you. Or at least till date, I have never seen a question being asked about polar vortex formation. That's why you don't need to learn unnecessary things. Let me tell you one thing. It's very important to know what you should not study. It's important to know what you should study, but it's equally important to know what you should not study. And that's why I'm telling you, don't go into the details. You don't have to do PhD. You just need to qualify the exam. Okay? That's why I'm telling you, this polar vortex is not allowed to come down because of a very strong polar jet. It stops this because this is a very cold air. I mean, imagine this is a polar region. This is a polar region. Okay? And what will happen at the poles? The temperature will be very much less. And these winds are very cold. They are stopped by this polar jet. This polar jet. And I told you already, the polar jet is formed because of temperature difference. I told you about its formation and all. We have high pressure at one place. Because of high temperature, the air rises up. Then there is less height, so the difference is because of the temperature as well. Why? Because high temperature, the air rises up. Low temperature, so a jet stream is formed. It meanders. Now imagine what we humans do. First of all, look at this image. This is a polar vortex. We'll go into the detail as well. That's present on the North Pole or the Arctic. Okay, and this is a jet stream that's blowing. It stops this polar vortex from coming down. It does not allow this polar vortex to come down. Correct? Now, what we humans are doing are playing a great role in destroying the climate, environment, everything. We have led to global warming. Because of global warming, the temperatures have increased. Correct? Now, since the temperatures have increased, I told you the polar jet that blows here. Okay, this is a polar jet that's blowing. Now, when the temperatures increase, what's going to happen? This jet stream will start to meander more. Why? Why will it meander more? Because the temperature gradient is already. See, we had ideally, let me try it again just to make you understand. Listen, ideally, we had a condition of very cold temperature here, warm temperatures here, and because of this temperature gradient, we saw the jet stream moving like this. Now, what we are doing is global warming. And because of global warming, this very cold air is slightly warmer. It's not hot or warm, but slightly less cold as compared to the way it was. Because it's less cold now, the temperature gradient is less. What will that do? What will that temperature gradient do now? The temperature gradient decreases, and because of that thing, what happens is that the polar vortex will start to come down. Why? Because the jet stream will become weak. It will start to meander more or even break at places. It will start to meander more, and because of that thing, the polar vortex that was ideally stopped here, it was stopped here. Okay, it was stopped here. Now, because the jet stream is coming way south, because of intense meandering, the polar vortex will also come south, and it will bring very cold temperatures because I told you the winds are very cold. Ideally, the winds were stopped by this jet stream in the northern part of the planet, in the northern Canada or all let's talk of Northern American region. Now, because of the intense meandering, the polar vortex has come down a lot, and because of that, the polar vortex brings intense cold weather in USA. That's what has happened. A chunk of polar vortex sometimes slides down towards the US. This funnel bitterly cold Arctic air over the central and eastern US. Now, that's okay. The polar vortex comes down. But why does it come down? because of the fall in temperature gradient, because of the polar jet stream becoming weak, because of intense meandering. The polar jet, when intensely meanders, it cannot stop the polar vortex in the northern regions. The polar vortex also comes south, and it brings intense cold weather conditions in US. I think you're not able to figure out how cold the conditions are. It can be minus 40-degree temperatures, minus 50-degree temperatures. It's not cold like we have in India, maybe 2 degree, 3 degree in winters. In Delhi, we say it's cold. In Kashmir, see, I live in Kashmir. We know it's very cold. It gets to minus 15 degrees and it's very cold. It's bone chilling. I can tell you something. It's snowfall. It's very cold. So I can only imagine minus 40, how it will be. Minus 50. It's very devastating. That's the condition that happens. And this is what the news was this year. That's why I told you, you need to connect the dots. You connected the things with heat wave. But there is a condition where in United States of America, a polar vortex expansion was expected this year around Chicago and all. Severe cold was seen in US. And what was the reason? You might get this question in your exam if you're writing mains. The severe cold conditions in US. What was the reason? How has polar vortex played its role? How is the global warming responsible? Every aspect needs to be covered. Global warming, what is the role? It weakens the polar jet. Polar vortex, what? It comes southwards because of weak polar jet. And there were very severe conditions in US, minus 40, minus 50. Now, I'll tell you one very important thing. Of course, Mr. Donald Trump in 2019, when the temperatures fell to minus 45 degree, minus 45 degree in Chicago. In Chicago, the temperatures were very much, you can see minus 60 degrees as well. He's mentioning in his tweet in 2019. Okay. What this great man, Mr. Donald Trump, said was that where is global warming? You guys are talking of global warming. See, what the hell is going on with global warming? Okay, the temperatures are so much less. And you guys are talking of global warming, but the temperatures are minus 60. Ideally, what we think is that global warming is only related to high temperatures. That's not the case. Global warming is associated with climate extremes. And why am I saying that? Because if you know that this condition was clearly a result of global warming. Why? Global warming, pressure gradient less, more meandering, more temperatures falling, because when that meandering is more, polar vortex came southwards up to Chicago and temperatures fell to minus 60. Donald Trump failed to understand it's the global warming that's causing this. See, uh, I know, I mean, you can criticize me, maybe you guys may be a fan of Donald Trump, but this was something that should not have been there. See, please come back fast. We need you. What? Global warming. Because if there was global warming, the temperatures would not have been minus 60. But the fact is that it's the global warming that's causing this fall in temperature. You need to link the dots. You need to understand the questions. How is global warming? You might appear in mains. And the question is there, how is global warming responsible for the fall in temperatures in US? And you might get a shock that minus 60-degree temperature in US, and how is global warming responsible for that? That's not possible. If the temperatures are 40 degrees, 50 degrees, you might be okay, yeah, it's global warming, that's why the temperatures are high. But when you see a question minus 60 degrees and global warming, you'll be like, no, this is not possible. But it is global warming only. And that is why you should not make a mistake like this in the comments, in the tweet, or your knowledge. Learn about things, then talk about them. Okay? You're going to be future officers, future civil servants. You will, of course, know about these things. So that's how you should approach your subject. Link the things to current affairs. And that's all from my side. I hope everything's clear. And if there are still any doubts, kindly drop it in the comments so that I can answer your doubts. Okay? See you next time. Till then, bye bye. And you keep revising your stuff. I'll see you soon. Okay.